Okay, so I'm gonna try my best to kind of explain what we were talking about yesterday. Hopefully you watched the videos already, and this will just kind of clarify some things. So, as you kind of already know, here's our nucleus, and then each of these layers, we can call like an energy level, or we can call it like a shell or something. So the phrase we usually use is PEL, principal energy level. Principal energy level 1, 2, 3, 4, etc. Now, as you notice, as you get further away, that circle gets bigger. So there's room for more electrons on that circle. Generally, the way that we do it is by the number of subshells that are located in that energy level. So the first energy level only has one subshell. It's called an S. The second energy level has two, S and P. And I know I kind of briefly mentioned them, but I'll get deeper into it today about what's actually in these subshells. Principal energy level 3, SPD, 4, SPDF, and we just go on from there. Now, generally, we don't go too much further, but there are some subshells after that. Now, within these subshells, you can kind of think of them as like houses or so. Each house has a different number of floors. So an S orbital, or an S subshell, only has one orbital, and an orbital holds 2 electrons. Orbitals are like the probable location of an electron, just somewhere in that floating region. So if we scroll up a little bit and we take a look, here's hydrogen. Here's the nucleus, and here is its electron shell. Somewhere in this dotted area is its one electron floating around, and imagine it like a sphere, a 3D shape around it. One electron somewhere in there. That's the S. P is a little bit trickier, but that's only located on that second level. So here, if we're looking at nitrogen, we have our nucleus. I'll do maybe pink for my electrons. So I have 2 electrons floating somewhere on that S orbital, on that first principal energy level. Now my second energy level has both an S and P, and there's actually 3 different P orbitals. And P are these wacky, like dumbbell, barbell shaped things, whatever, that go in 3 directions, X, Y, and Z. So like up and down, left and right. So another one that goes this way, they don't really overlap. And then another one that would be going like out of the screen towards you and then into the screen away from you. So those are our 3 P orbitals. We usually say X, Y, and Z for their like location on a plane. So we have 2 electrons somewhere in that sphere, and then we could have up to 2 electrons in each of those P's. So when we go down here, we have that idea that the P subshell has 3 orbitals, meaning a total of 6 electrons. D has 5, and the shapes are all wacky. You saw some pictures in the notes and on the video earlier. All we know is 5 orbitals, 5 times 2 is 10, and the F has 7 orbitals, even wackier shapes, giving us 14 electrons. Putting this together, you can see that first energy level is going to hold 2 electrons. Second can hold 8 because I'm adding up these 2 orbitals. The third one, I'm able to do all 3 of those, which is 18. And then fourth has all 4 subshells with a total of 32 electrons. And we just kind of keep going from there. What does this matter? How does this whole thing work? Well, when you look on the periodic table, they give you like a basic outline of the electron configuration. But if we want to know exactly where those electrons are located, we need to understand what orbitals get filled in what order. There's a real simple way of doing it. I think I have it drawn out already. Here. We fill like this. This first. Then this. Okay? And we use this throughout the year, but it's just kind of the order at which those orbitals are filled, and we basically denote them as 1s, 2s, 2p, 3s, 3p, 3d, and so on. Let me just do it, you see how it works. So with hydrogen, it's really simple. It only has 1 electron, so it'd be 1s, so it's the first energy level, the s subshell, 1 electron, done. Something like nitrogen, taking a couple steps further. So we have 1 2s2 because there's 2 electrons in that first subshell. And then we have a 2s2. And then we're going to have 2p, whatever's left over, 3. Basically what we did is we had 5 electrons in this second shell somewhere in this second shell area. So we put the 2 in the s first, and then we put 1 in each of those p's. 2p3. Generally, if you add this up, it's going to equal that. You add all the 1s up, they equal that. Let's keep going. You'll get a hang for it. Si. 1s2. That covers my first. Here's my second. Here's my third. 2s2. 2p6. Those are my 8. Everything's filled. Check. The next place I go, 3s2. And then it's going to be 3p2. P's add up to 4. Great. That's my extended electron configuration. We'll do potassium next. 1s2, 2s2, 2p6. That's that. That's that. 2s2. Oh, oops. 3s2, 3p6. Those are the 8. Now, I know the third shell can actually hold 18, but we're going to fill that 4s1 first. And you can see that here, how after 3p goes 4s. Then we go back to 3d. And you'll see that on the next one. Here with bromine. 1s2, 2s2, 2p6, 3s2, 3p6. Then we actually go to 4s2, 3d10. Oh boy. Look at our 3s. 18. Check. Our fourth one has 7 though. So the next thing we go after 4s, 3d, 4p. 4p, how many do we have left? So 7 minus 2 is 5. 4p5. Okay, that's probably as far as you'd ever go with this. And there's a little bit of a trick. Instead of writing out all this nonsense, what you can do, these are the noble gases. And these have a full shell. Notice how everything finishes with an 8. So they're happy, they're stable, everything's all good here. Sometimes what you can do is you could just replace all this nonsense with one of the noble gases. And you can just say, okay, what has that set up? So like a 288. Okay, 288. So I could just do argon like this, AR with a bracket, and then put that after. That's actually included. So 4s2, 3d10, 4p5, done. And I actually saved a little bit of time. There's obviously a little bit more, but I don't want to go too much further. So we have this. Maybe I'll give you some practice questions, or feel free to text and ask me any questions.